Hey everybody, welcome to ReactJS Dublin. Very glad to have you here on this fine Wednesday evening. This is our first meetup since about August 2019, so we've been away a while. We have a different format, obviously, this time around. We're trying out the virtual thing. We had a good few respondents here for the event. We had about 140 people respond altogether, so really good turnout, and we hope you have a really good time with this talk, and you get lots of good hints and tips from our speakers. Just a little bit of information about the ReactJS Dublin meetup itself. It's been going for a number of years now, and we've had lots of talks on even from beginner modes, beginner concepts in ReactJS, all the way through to advanced ones. So we try to cater for as many people as possible. If you want to kind of see a particular talk, we're going to give you a Google form link, and reach out to us. And if you want to give the talk yourself, or if you want to maybe have a talk, have somebody else give the talk, we'd be happy to take submissions. Obviously, this time it's a little bit different. We have less interaction. It's obviously not the same as an in-person event, and we don't have any free pizza or free beer for you. Sorry about that. You're not getting any little care packages to your home or anything, but hopefully you get the same out of it that we put into it, and we hope we see each other in person really soon. So yeah, just next slide there. A big call out to our sponsors, HubSpot, who have been sponsoring ReactJS since its inception. So we get the free space in HubSpot. We get this amazing kind of virtual events. HubSpot are currently recruiting as well. So we have a lot of open roles for software engineers and developers. You can reach out to any of the HubSpot staff through Meetup itself, or just visit hubspot.com/careers, and you'll be able to see it yourself. Next slide. Just a few notes about the event itself. You would have got an email earlier on about the code of conduct. We take that very seriously, so we want to create a safe space for both attendees and speakers. So it's very important to us that you read and understand that, and your participation in this event is basically an acknowledgement and an acceptance that you accept those terms. If you have any questions about the code of conduct, please feel free to reach out to us on Meetup, and we'll do our best to answer. As I say, this is our first virtual event. There may be some teething issues. We'll learn from them. If you feel like you want things to go differently, or you feel like we can make improvements, again, please reach out to us. The format is going to be as follows. So we have two great speakers tonight. We're going to play some kind of pre-recorded videos. During the video, the speakers are with us as well. So during the video, please feel free to ask questions through Slido. And then I'll go on to the Q&A format in a second. But after the video, we'll have a Q&A session. And yeah, you'll be able to ask questions, and then we'll move through the videos. And at the end, we'll just do a wrap up and a couple of other notes that we want to reach out to you about. The last thing I'll say is on this is that we do have a call for speakers. We're always looking for people to speak at these events. So go to this URL here, bit.ly/reactjs-cfs. We'll share this. This is shared on the Meetup event as well. If you want to submit a talk, or you want to see a talk being submitted, please feel free to reach out to us there. Next slide. The Q&A format, we're going to do the Q&A format after each session, after each video, rather than lump it all at the end, because it's really hard to kind of decide then which questions go to which people. So it'll be about 15 minutes of Q&A. Do add your questions during the sessions themselves, because then you'll get the opportunity to upvote good questions, and don't downvote bad questions. No such thing as a bad question. But yeah, so upvote them, and then we will pass those questions to the speakers. I'll be asking the questions interactively of the speakers in the first session, and then my good friend Alvaro will be passing the questions to the second speaker in the second session. Next slide. Yeah, so just to contact us, reach out to us on meetup.com. the ReactJS Dublin page, or we're also monitoring the ReactJS Dublin Twitter hashtag. So yeah, if you have any comments or you want to share anything about the event, please do it there as well. Next slide. So yeah, a little bit about our talks. So we have 2 talks tonight. First up is Marlon, and he's going to talk to us about GraphQL and Apollo Client. Really good talk. And the next topic is React and TypeScript. So George is going to talk about that. They're about 20 minutes long each talk. We have about 15 minutes at the end. So plenty of time to get your questions in, and really good content, and we hope you enjoy it. I'll hand you over to Marlon now. Marlon is a senior software engineer at Workday. He's been there for about 2 years. He joined in April 2019. He's on the UI platform team as well. So they're responsible for building like really robust, scalable user experiences to Workday. We're Workday users. I'm sure there's a lot of Workday users in the audience as well. So there's a good chance that he's worked on something that you're using at the moment. They use a range of different technologies. They use Java and on the back end, and they use React on the front end. He's been exposed to like Apollo Client, Cypress, Emotion, and Jest for testing, Webpack and Storybook, like your regular kind of Jamstack stuff. So he has his LinkedIn details on this slide. So we will share this slide at the end of the talk. We'll leave it up. So if you want to reach out to him on LinkedIn, please feel free to do so. So with that, if we could show Marlon's presentation, and we'll pick it up after that.
All right, so let's talk about GraphQL and Apollo Client. So before we dive into that, I just want to have a look at what this talk is about and what this talk is not about. So today we're going to have a quick intro into GraphQL for the folks on the call that may not know what GraphQL is. We're going to be talking about the benefits of using GraphQL. We're going to have a quick comparison between REST and GraphQL, and then we're going to conclude by talking about how to handle GraphQL with Apollo Client from a client application perspective, right? So what this talk is not about, so we're not going to be covering like how to create and manage a GraphQL server, how to create a schema in GraphQL, nor how to build GraphQL APIs. So again, just to emphasize, the whole point of this talk is to focus on the client side and how to deal with client GraphQL from a client perspective. So let's dive straight into it. So quick intro into GraphQL. So GraphQL is basically a query language for APIs. So the way I like to think is I like to compare it to a database, right? So we all know how to get data out of a database. We basically write a SQL query specifying exactly what we wanted to get out of the database. And GraphQL is basically the same. It's the same concept, right? The only difference here is that instead of querying from the database, we actually querying from a set of APIs. So that's basically just a query language to get for APIs. So GraphQL has basically 3 main characteristics. So one, and the most important, I think, is that it lets the client specify exactly what it needs, right? So it's everything, the communication between clients and server is driven by the client rather than being the other way around. GraphQL also makes really easy to aggregate data from multiple sources. So let's say you have like 5, 10, 15, doesn't matter how many APIs on your backend. Rather than having to consume each one of those APIs individually, and GraphQL allows you to aggregate all that into one single schema, and that schema is what the client talks to. So the client basically has one single point of entry to talk to all of your APIs, right? And to get all the data that it needs to build its view. And then finally, GraphQL uses a type system to describe the data. So that plays along really well, specifically if you are using TypeScript in the client application. So by having the typed data on the back end and the typed components on the client, like it's really easy to make that integration between your component props and the data that's coming back from GraphQL. So what is a GraphQL query string, right? So I think like for this, it's important to note that GraphQL is nothing more than a regular post request where the body of the request is a query string with the data you wanted to get out of GraphQL, right? So that is basically a regular post request that is then sent to the server. The server fulfills that request and sends it back to the client as a JSON object. So I have an example here of like what a query string from GraphQL looks like. But before I talk about it, I just wanted to point out the tool that we're seeing here. It's called GraphQL. And that is a tool that allows you to easily explore the scheme and understand what's going on in there and what you have available from a client perspective. So GraphQL, as you can see, like on the top, on the top here, the image, we have the actual entry point for the GraphQL schema. And that, as I mentioned, that's like the single entry point that you have into your GraphQL schema. And then on the left-hand side, you have the query string itself, and then on the right-hand side, you have the response. So if you look at the query that we're sending in this case, we're actually asking for the resources called all users. And then from that resource, doesn't matter whatever is available on that resource, we are specifically saying, hey, give me the ID, the name, and the email. Now, this is an interesting part as well. We're also asking for the friends sub-resource, right? So friends is sub-resource of all users. And then friends, the friends resource also has its own set of properties, right? So in this case, I'm saying give me the ID, the name, and the email. So it doesn't matter whatever else is available on the friends, I only gonna get those 3 fields. Now, this is a really, it may seem very simple, but it's a really powerful query string, right? Because let's say from a regular, like if you imagine that you may have a friends API and a users API, if you wanted to build that data on the client side, you're probably going to have to send a request to get all users, then look at the response from that request, and then go back and fetch all the friends based on the user that you're looking up for, right? So that basically means 2 different requests on the client. That means you need to synchronize those requests on the client, and there's a bit of complexity that you need to handle on the client side before you can actually show the data to users, right? And in the case of with GraphQL, we actually able to send one single request over the wire, and that request would then be responsible for getting all the data we need, including the friends sub-resource in this use case, which then by the time the response gets back to the client, we know we have all the data we need to build a page without having to worry about synchronizing and sending a second request to get the remainder of the data. So this is a really interesting point. Is a really cool thing to notice, even with a query as simple as this one, right? And then you can see, like on the right hand side, what we have the response, right? And the response has a list of users with only the data that we ask here, so ID, name, and email. And then we also have the list of friends, which also has only what we asked for. So again, really interesting and really simple way to see how to build a query string and what kind of response you're going to get out of it. So I think that the takeaway here is you can build your query string, which is basically a more or less an object, right? And then within that object, you specify exactly what you want to get from the server. So what are the benefits of using GraphQL? So one is a declarative data fetching. So it's basically, as I mentioned before, is a UI-driven data fetch system, right? So with GraphQL, the client is telling the backend what it needs, rather than the backend sending everything it has to the client, and then letting the client manage the parsing and the consumption of the data and what it needs to show or not on the screen to users. So that's really powerful in its own, right? Another thing that GraphQL provides or prevents is over or under fetching, right? So because everything is driven by the client, you're never going to run into a scenario with GraphQL where you're going to be getting more or less data than you actually need. So this could be a problem, for instance, if you have an API that's supposed to support different clients, right? So let's say you have an API that's supposed to support both a mobile client and a web client. So a lot of the times your mobile client and your web client may look slightly different, and they might behave slightly different, right? So the API for those 2 may be a bit different. So if you have one API that supports those 2 different clients, one of them will be over or under fetching, right? So you're going to need to handle that on the client side. Or you would run into a scenario where you would have the same API, but built twice with small tweaks to fit in with its mobile client and its web client, which is not a good approach, right? So with GraphQL, you basically decouple the client from the backend, meaning that from an API perspective, you're able to build your APIs in a very generic way. And you're able to expose that not only to your mobile and web client, but you can even go further and expose that API to customers, right? So make that API public, because at that point, you're building your API not coupled to a specific client. So that makes your API really powerful. As I mentioned, like with a tool such as GraphQL, it's really easy for you to navigate through the schema and to see what is available on your GraphQL schema. So when it comes to consuming REST APIs, I feel a lot of the times client developers, they rely on really good documentation from an API side perspective, or in a really good communication with the backend team, right? Now with GraphQL, you basically have the documentation inferred within the scheme itself. So if you have something like GraphQL, you can basically go into the scheme, explore, and see what's available there, and see exactly what you can consume from the client side. So that on its own, it makes our life much easier, right? Another thing that I think is a benefit of GraphQL is the fact that it's has a really modern ecosystem around it. So GraphQL itself is a relatively new technology. So it was actually created by Facebook back in 2015. So it hasn't been too long yet, right? And since its creation, like, it has seen a massive adoption by the industry. So there's a lot of really cool stuff and a lot of cool tooling around it, which makes it really easy for us to adopt it, right? So one of those tools is Apollo Client, which I'm going to be touching in a second. But that's just to say there's a lot of really cool and modern stuff around GraphQL that we can leverage on the client side as well as on the server side. And then, of course, if you combine all that, it means that we're going to have a much more simplified code, right? So if we can send a request to the server requesting for all the resources we need without needing to send multiple requests and then syncing that back into on the client side. And if we use tools like Apollo Client, which gives us caching and state management, and then tools like GraphQL, which allows us to explore the schema and understand what's there, all that contributes to providing a much better developer experience for us client developers, right? So, and it also means it's simpler code on the client side, as I'll show you once we go into the Apollo Client piece. You see how simpler the code it is when it comes to consuming data from the GraphQL schema. So at the end of the day, all that contributes to a much better developer experience, which at the end of the day is what we want, right? We want a better developer experience because that makes our jobs easier and allow us to focus on what's important, which is building a good product, right? So what are the main differences between REST and GraphQL? I think REST is basically is the way client and servers communicate today, right? It's doesn't matter which website or application you go through, you're probably gonna come across some sort of REST communication happening there. So REST is really good. It does a really good job, but it has a few drawbacks, right? So for one, it's very chatty because you have all those different resources, and depending of the page and what you're trying to do on the client side, you may need to go to the server multiple times to get all the data you need to build your view. So it can be very chatty, right? Which means that you may not be able to build a really good user experience because you're having to go into the server so many times, and you need to kind of coordinate and sync and before you even show something to customers. So that is one thing. And second, it's one thing that I touched already, is the fact that REST is really coupled to the client, right? So from an API perspective, if you ever wanted to build your API should be adopted by a broader community, you're not going to be able to do that in a proper way or in a scalable way by leveraging REST, right? Because REST is really tied to specific clients. And that's where GraphQL comes into play, right? So to me, I see GraphQL as a natural evolution from REST. So one thing is that it basically aggregates all those different resources, right? All those different APIs you may have in your backend. It aggregates all that into one single schema that makes it really easy to be consumed by the client. It also means that it only has one single point of entry. So for instance, when we're talking about REST APIs, it means that a client application needs to keep context over all the different endpoints that it needs to consume when it comes to getting data from the backend. And GraphQL basically eliminates that because you only have ever one single point of entry, right? So the client application only needs to maintain that context. And of course, the most important piece is the decoupling between client and backend. So now you can build your client the way you want, and you can build your APIs the way you want, the relationship between them is not coupled. So so you're basically able to expose your API to many different clients while maintaining each one of those clients in a performant and scalable way, because none of them will be over or under fetching, right? And they will be much less chatty because you basically have one schema which has all your data there. And you're not gonna need to go to the server multiple times, let's say, to build a view that may need different resources to show everything you want. So so again, I think the most important piece here is this decoupling between client and backend that GraphQL provides. So now that we have a basic idea of GraphQL is, right, how do we handle GraphQL with Apollo Client? So before that, let's talk about what Apollo Client is, right? So Apollo Client is nothing more than a open source JavaScript library, and it basically allows JavaScript applications to communicate with a GraphQL backend in a very easy and concise way. So as I mentioned before, GraphQL itself is nothing more than a simple post request where the body of the post request is your query string, right? So you technically don't really need Apollo Client or any other library to manage GraphQL from a client perspective. But because Apollo Client provides a whole lot of features and it simplifies the way you consume a GraphQL schema, it's definitely worth having a look at it. And it's definitely something you need to consider when thinking about bringing GraphQL into your ecosystem, right? So you can either keep your bundle size relatively small, but having to handle all the GraphQL communication and all the GraphQL pieces on your own, or you can bring something like Apollo Client, which does a whole lot of stuff for you. And when I say a whole lot of stuff, I mean basically does three things, right? One being state management. So Apollo Client has its own state management piece, which it can, in a sense, replace something like Redux, right? So if you have an application today, a React application using Redux, and you're gonna bring Apollo Client into your repo, you can think about like, can I drop Redux and replace it with Apollo Client state management, which is something that is it's doable, and I've seen it done before. Now there's a big debate in the community when it comes to how good it is. It's a Apollo state management piece. Some people are very positive about it. Some people are very negative about it. So that's just an important thing to note, right? So nonetheless, is an option that Apollo Client gives to you. And it's something that of course you need to investigate and see if it fits your use case, but nonetheless, it's an option, right? So it's always good when a library that you're taking in gives you an option to solve the problem in a different way. Apollo Client also gives you cache management. So you're able to manage the client application caching through Apollo Client, which is really cool because we all know caching is one of the hardest problems in computer science, right? So the fact that we're able to get that for free with Apollo Client is a really cool feature. And then the last one that I have in here is integration with React. So I'll show you in a second, but you'll see that you can basically, like, Apollo provides a whole set of hooks that you're able to consume in your React application, which makes that integration with the rest of your code base much more streamlined and straightforward. Of course, like, Apollo provides a whole lot more, but I think those are the main pieces that you can take away with Apollo if you decide to bring that into your code base. So now that we know what Apollo Client is and what it can provide, how do we actually use it in our code base, right? So you basically need two things. You need a client instance, which is basically your configuration, and you need a provider. So let's have a look at this. So this is a simple code. So you can see on the left-hand side, we have the Apollo Client instance. So you can see, like, for instance, on line 6, we're defining the entry point for the Apollo Client, or for the GraphQL schema. And as I mentioned before, this is the single endpoint, and that's all we're going to be hitting when talking to the server, right? And then you can also specify your caching policy, your fetching policy. So for instance, in this case, you're saying caching network, meaning that we're always going to check the cache first. And then if it's not in the cache, we're then going to go to the network. But you can define, like, there are different policies you can specify here. So you can always use a cache, or always use a network, or have a different sort of combination there. But nonetheless, that's where you basically define your global Apollo configuration, right? The configuration that it's gonna apply to every single time you consume a query through Apollo client. Once you have that client instance defined and configured, that's where you then need to. That's why you use it with the provider, right? So the provider basically is very similar to a Redux provider, to an emotion provider, where you basically wrap your application or your component, depending on where you're going to be plugging the GraphQL piece into your application node tree. So you basically wrap, let's say, this is wrapping my application, right? I want to wrap my whole application around this guy. So in this case, I'm wrapping my application with the Apollo provider, and the Apollo provider has a client property, and that property basically receives the client instance, which we have defined on the left-hand side here as that prop. And then with that in place, you're good to go. Apollo is all set, and you're able to consume your GraphQL schema on your React application through Apollo client. So how do we do that now, right? We know what it is. We have the setup. We understood what the setup is, which is it's very straightforward, right? Really easy to do. How do we consume it? There are, as I mentioned, there are a set of different hooks of how we consume data through Apollo client, or how do we write data back into our backend through Apollo client. So I'm going to touch on a few of those. And I think the most common one you're going to see, and you're probably going to be using, is called use query, right? So from a client application perspective, a lot of the times we're just consuming data from the backend. So we're just reading data and plugging that into a nice view. So that's where the use query hook comes into play. So as you can see, this guy basically takes two parameters, one being the query itself, and you can see the query is defined here. And the query, as we saw before, is a query string, right? So in this case, the only difference compared to what we saw before is that we actually have a parameter being passed into this query where we specify which language we wanted the message to be. And this is basically, as I mentioned, it's just a parameter into that specific resource into your GraphQL schema. So as I mentioned, as I was saying, the first parameter is just the query string itself. And then the second parameter is an object. And that object can have a whole lot of stuff. In this case, we have variables, which itself is an object. And that's why we define the variables we're passing onto that query string. In this case, we're passing language as English, but it could be whatever, right? And then that's where we also would be able to, let's say, override the global definitions that we specified on the Apollo client instance. So let's say, if I wanted to have a different fetching policy for this specific request, that's where I would put that override fetching policy. So as we saw here, the fetch policy in this case is called, we define it to always go to the caching first and then the network. But let's say I wanted to do something like I always go to the network for this request because I always wanted to make sure I have the most up-to-date data, or like I know the data for this specific resource is very dynamic, it's changing constantly. So I don't want to be looking at the caching for this guy. So that's why you basically would say you would specify the fetch policy as part of this object, and then Apollo client would know that for this specific request, you would always need to consider that fetch policy rather than the global one. So very simple, very straightforward. And then what that guy gives you back is actually an object as well. That object has a whole lot of stuff, but I think the three most important ones are the ones listed here. So you get a loading state, you get your error, and your data. So of course, like this guy will be triggered as soon as the component is rendered. So you're gonna get a loading state, a loading flag indicating if like the request is being processed or not, which you can then leverage that to render a specific view for your component. And then once the request is successful, right, or once the request is completed, then you're either gonna get your data or you're gonna get an error, which then you can do something with it. So like really, really simple how Apollo and how the use query hook in this case makes it for you to consume data from your GraphQL. So all you got to do really is write your query string, which if you're using something like GraphQL, you can basically copy and paste whatever you have from there in here. And then you're just reading the response back from the hook, and then you just render your component based on that. Now, as I mentioned, use query it's triggered as soon as the component renders. So there are cases where we might actually want to trigger a request to only happen whenever there's a user action, right? So that's where the use lazy query comes into play, it's basically the same. It does the same process as a use query, but instead of being triggered immediately, it actually returns to you a callback function that you can then call it at a later state. So if you look at this guy here, same definition. It takes the query string as the first param, and the query string is the same as the one we saw in the previous example. And it also takes an object, which in this case only has variables, but you could also have fetch policy and whatnot. And then the difference here is that the response looks a bit different, right? We still have our object with loading and data and error, but in this case, there's actually two things we're getting back. We get the callback function, as I mentioned, and the object, which has then all that we need to render our view, right? So we'll see here that the load greeting callback function is actually called whenever the button is clicked. So rather than the request will not be sent to the server as soon as this line is evaluated. The request will only be sent to the server once the load greeting function is called, and that happens, as I mentioned, on the click of the button, right? So once that request is sent, that's where your loading state and your data and your error and whatnot will be populated. And in this use case, we also have this called Boolean value, which allows us to kind of like play around and evaluate if the request has been called already or not. Which again, this is all being done on the background by Apollo Client, and all we basically is just leveraging those values to then build the views the way we need. So again, super easy and super powerful to build a really readable component leveraging those hooks, right? Now there are a few other hooks within Apollo Client. Two that I think worth mentioning. One is called use mutation. So the two examples I showed you before, they cover how you get data out from the database or out of your APIs, right? Now the use mutation is the other way around. That's how you write data back into your database and, through your APIs. So within the GraphQL scope, we call that a mutation. So Apollo Client has a use mutation hook, which is very similar to the ones I showed you, with the difference being that instead of consuming data, you're writing data back into your backend. And then another one that I think is super interesting is called use subscription. So use subscription basically allows you to create a pub/sub system between your client and your server. So it basically means that your client application, whenever you use this hook, subscribes to a resource that's available on the backend. And whenever there's an update to that resource, whenever data is updated within that resource, a message will be sent to the client saying, hey, this resource has been updated. Do whatever you need to do on your end. So then the client can then re-render the view or send a second request if that's the case. It doesn't matter what it is. At that point, it's up to the client to decide what he needs to do once he gets that message, right? So really powerful stuff. This one, of course, like requires a little bit of tweaking on the server side of the schema as well. But nonetheless, it's a really interesting option available to us to be able to keep a connection open between the client and our GraphQL schema, right? So with that in mind, that's it for me. Before I go, I just wanted to point to bring this up. So Workday is hiring. It's a great company, great team. There's a lot of really cool stuff going on at the moment at Workday. So definitely a really good time to join. If you're interested or if you're thinking about a change, have a look at some of those links and see what you think. And with that in mind, that's all I had. So thank you. Hopefully you learned something. Hopefully you enjoyed, and talk to you soon. Bye.
That's great, Marlon. Thank you very much. Everybody say hello to Marlon. Welcome, Marlon. Thanks for being here this evening. Yeah, so really good presentation. I thoroughly enjoyed it. We've got some really good feedback from the audience already. What I'm going to do is I'm going to kick into the questions straight away. There's a couple of general questions which I'll answer, and then I'll pose the upvoted ones to Marlon. And what we're going to do in between sessions is we'll archive the questions so that we don't run the risk of asking the same question twice. So Marlon, I hope you're ready for this.
Yeah, let's do it.
Yeah. So first question we have here is, I would probably ask this question myself as well, is do you view GraphQL as a tool to replace or to complement traditional REST APIs?
Yeah, no, that's a good question. I think the way I see GraphQL is basically an alternative to REST, right? I think it's really based on the use case you have for your backend, your APIs. So you probably heard me talking a lot in the presentation about over and under fetching, right? So if you have, if your backend is supposed to support different clients, so like your mobile client, your web client, and whatnot, and those clients, they have different needs and they consume the API from different perspectives, right? I think at that point you do want to consider GraphQL as your solution. However, like if you have like a simple single client, and that's your only use case, I don't think like REST probably does the job for you, right? And I think it's interesting with REST as well. And there's nothing in a sense that you can do with GraphQL that you cannot do with REST. So for instance, one of the advantages of GraphQL is that the client basically drives the communication, right? The client picks and chooses whatever it needs. Technically, you can do that with REST, right? So you can, let's say, I've seen people doing that at certain places where you have maybe like a query param where you define the fields you want to pull from the API, right? So you can technically do the same thing with REST. I won't say that's the most elegant approach, but definitely doable, right? So not a replacement, more like an alternative that you need before you jump into it. I guess you need to evaluate your use case and then see if it fits with it or if it doesn't, right?
Very good, yeah. A general question. Well, sorry, we have a woohoo ReactJS comment here, which I'm just gonna let's mark that one. Okay. Next, yeah, we're all happy to be back. The next question here is: if I don't want the client to have access to all the items in the database, how do I configure that?
Yeah, another good question. So again, like the point of the talk was more on the client side. But if you think about GraphQL as a whole, right, you basically have three main pillars. You have the queries, which I talked about on the talk, and then you have your schema, and then you have your resolvers, right? And your resolvers are basically what's sitting on the back end, and it's what actually gonna execute the queries come from the client. So within your resolvers, you can actually, that's where you implement your security, your limitations, your guardrails to make sure that the consumers only have access to what they actually can, right? So for instance, like if you implement a limit on your API, you can reinforce the limit at a result, like on the resolver, right? And that's basically within that scope, that's where you basically control like all the security and the restrictions around what can and cannot be consumed from your backend from a GraphQL perspective.
Yeah, that's the differentiation we're making, is that there's only so much that you can do on the client that you need to basically back that up with your business logic within your resolvers to prevent, that's your data access layer, you know what I mean?
Exactly,
yeah. How does Apollo differ from other GraphQL clients, like say, for example, Relay?
Yeah, no, good question as well. Be honest, like I haven't really used Relay in the past, but we did investigate Relay at Workday when we were deciding between Apollo Client or other libraries, right? So we did a comparison between Relay and Apollo Client. And a few things that stuck out. One is that Relay is really opinionated. So you really have to do things the Relay way, which may not necessarily fit within your use case. So if you heard about Relay, you probably heard that it's something that was developed by Facebook, just kind of like GraphQL, right? But Relay was really like a library developed by Facebook to fit Facebook needs, right? So it almost feels like you're trying to use a Facebook library to your own use case. So you're trying to adapt things in a sense. Another thing that we found is that the documentation for Relay is really, I want to say poor, but I don't want to sound too harsh, but it was really incomplete and not really good, to be honest with you. As if you go into the Apollo Client documentation, you actually, like, it's a really clear documentation. It's really easy to find stuff. It's not perfect, but it's much better than Relay. And I guess like the community as well. I think there's definitely been a huge adoption by the community with Apollo Client, and that means it's easier to find resources. It's easier to find help, right? So that all, I guess, counts as a negative against Relay and other libraries when it comes to comparing that with Apollo Client. So it just like documentation, community, and the fact that Relay is so opinionated makes it, just like for us at Workday, it made sense to go with Apollo Client because it gave us the flexibility we need and the support we want.
Yeah, and I also found like more often than not, Relay was very opinionated and kind of they like to do things like they like to deviate from the specification quite a lot.
Yeah.
So that kind of jarred with me quite a bit.
Definitely.
Quite another question here. How does the aggregation of the different resources on the backend work? I presume we're talking about the resolver side of things here.
Yeah, again, it all comes down to the resolvers, right? So you can actually have different backends on if you have a GraphQL scheme, right? So you can have a Postgre database, you can have a MySQL database, whatever. All that, like that aggregation layer really happens at the resolver level because that guy will be the one actually executing whatever queries are coming from the client, right? So it really comes down to that resolver piece.
Yeah, very good. Comment here. Great talk, Marlon. Keep spreading the good vibes.
Nice.
A question here, a general question. Do we plan to record the talks? Yeah, so we replied to this already. We are going to record the talks. We're going to put the YouTube channel link on the ReactJS Meetup page, but both talks are going to be recorded. We'll also put the slide information there as well. So, another question here: is one client enough, or do I have to? That just jumped. Or do I have to sometimes use multiple clients in the same application?
I guess when we're talking about client, we're talking about the Apollo client instance, I suppose.
Yeah.
If that is the case, you basically need one client instance, right? I don't think it makes much sense for you to have multiple Apollo providers, with each one of those providers having their own instance, unless you have different schemas in your backend, which that on its own is a totally different conversation that we could spend the next half hour talking just about it. So I think like if you follow the standard, right, you would have a single schema, which then would communicate to all your different backends, which means you would have a single client instance, and that will be all you need.
Yeah, and most of the backend implementations support things like schema stitching as well, so you can actually merge multiple schemas on the backend. But to your point about you shouldn't separate your kind of client instances on the front end. Create a single client instance. You get the benefit of things like fragment matching, caching, all of that really good stuff that you can do on the client by having it as one instance. If you start separating that out, you create problems for yourself. Oh, sorry. Let me see if I can find this question. If I want to do some computation on the server side before returning the result, can I do that in GraphQL, or will I end up writing REST endpoints for that as well?
Good question again. Because everything is going through that resolver, you can potentially add an extra layer in there. What we actually do at Workday, we actually sometimes we do need to do certain calculations based on the response that we get. So we basically have a kind of like a middleware layer on the client side where we get the response from GraphQL requests, and then we evaluate that at a client level, and then pass that on to the components to actually render the views. So not sure if that's necessarily like the best approach, but it's a approach, right? And there's nothing stopping you from doing the same, I guess, at a resolver level. Or if you have like maybe you have like a specific server-side implementation for your GraphQL schema, you can actually have custom logic in there to do things before the response is actually sent down back to the client as well. So it really depends of like your implementation and your needs. As I mentioned, like within Workday, for what we needed, it made sense to keep that on the client side. But yeah, if you have something custom or you want to do it at the resolver level, you can do it.
Very good. Another question here from the audience. How does the fact that most public APIs in the world, including major ones like GitHub or Google Maps, are built using REST principles fare against the presented idea that REST is not suitable for public consumption?
Yeah, no, pretty good question. I think when I made that statement, right, REST is not really good for public consumption, I'm coming from the point of view that if you have your APIs, your set of APIs, and you need to support different clients, right? So as I mentioned in the presentation and before as well, your web client, your mobile client, and let's say you also have like you make your APIs public, so customers can actually go in and consume your APIs, right? It's really hard for you to try and build something that fits all those use cases without creating an experience for each one of those clients that may not be the most optimal one, right? So that's what I mean, like by making your REST APIs public to a range of different clients. If you have one single implementation that's supposed to support all those different clients, you're going to be hurting yourself at some degree on each one of those clients by over or under fetching stuff, right? So when you talk about Google Maps and the other example, I suppose there's only in reality one client for Google Maps, right? So I guess like when you go into to Google Maps on mobile or on web, it's basically the same application. You don't see any differences in there, right? So you basically consume the same API. So REST in that sense does work, does what it needs to do, right? But if you do, again, going back to the example of Workday, like our mobile client behaves very different from our web client. So to have one single API that's supposed to support those two different clients, it's really counterproductive because one of the two will be hard to process. So I guess, again, going back to what I said before, it's really like you got to evaluate your use case, what kind of clients you have, how your API is supposed to be consumed to then decide, okay, yeah, REST makes sense for me or GraphQL makes more sense.
Yeah, that makes sense. I did know GitHub about 2 or 3 years ago, started pushing their public GraphQL implementation, but there was a lot of pushback against it because they had suggested that they were going to phase out their REST API over time in favor of their GraphQL API, and that kind of caused a lot of consternation. So, not the way to release GraphQL API.
I guess, yeah.
Where do you draw the line between having a generic schema and making the queries specific to different client needs, like doing any data manipulation and client needs a resolver, so it cannot be reused? I think you kind of answered this one, but anyway, did that make sense? Do you want me to ask that again?
Yeah, no, can you repeat it?
Yeah, so where do you draw the line between having a generic schema and making the query specific to different client needs? Doing any data manipulation the client needs in the resolvers so it can be reused?
Again, I think at the end of the day, you wanna have a single schema, right? And your schema is supposed to support your range of different clients, and then it's up to the client to then decide what he wants to pull out of that schema. Now, if you have custom logic that needs to be embedded at a resolver level that then can be shared across your clients, that's fine. But as I mentioned, like at Workday, we actually have some logic on the client side to kind of like a middle layer between the response and the actual rendering of the components, and that is due to us needing to have something specific to our client, right? So again, you want to have your single schema as generic as possible because that allows you to opens a lot of doors, right? Allows you to support whatever kind of clients you have, even the ones that you may not be aware of in case your API is public to customers. And then if you need something specific at a client level, you can think of implementing that on the client itself. Or if it's something that it's generic enough, as I said, you can throw that in your resolver and then let that be handled at that level.
I feel like we could have a whole separate talk on like GraphQL server and schema implementations.
Definitely, yeah.
There's so many strategies. There are so many strategies there that kind of make it an awful lot easier. You talk about kind of different clients having different needs. One of the things that GraphQL almost kind of sets aside is the whole idea of versioning, so that you don't you don't version GraphQL implementations. You rely on the specification and the schema to infer versioning. So this schema has this type, which has this field. The next schema has the same type, but has this extra field that you can also kind of, or this one is deprecated. I think that's one thing that they probably could do a little bit more work on the specification side of things. Mm-hmm. In large projects or large companies where backend teams, I like this question actually, where backend teams and front-end teams are often independent, which team should have the ownership of the GraphQL there?
Good question. Honestly, I don't think there's a right or wrong answer for this. It really depends on your needs, the size of your team, and how complex is your schema, right? So for instance, like at Workday, we actually have a team dedicated for the schema. So it's not neither the backend or the front end team, it's a team dedicated for that. And it could be the same at another large organization, or that could live with the backend team, because at the end of the day, like that the scheme is closer to the database than it is to the client in a sense, right? So it would make more sense for backend developers to be maintaining the schema. But there's nothing stopping you from having that being maintained at a client on the client side or by client developers as well, right? So it really, again, it really depends on like team size, scope, and how your GraphQL service implemented to see what makes more sense,
Yeah, I think that's particularly in my company. That's the way we do it. Is that there is a team who is authoritative for it, but everybody can contribute to it. So, and it should be incumbent on everybody to contribute to it. You mentioned that Apollo Client could replace Redux. That migration seems like a potentially big task. What will be the steps for it, and can it be done in phases?
I guess it can be done in phases, right? So one thing that I mentioned at the talk as well is like you can potentially replace Redux by Apollo Client state management, but there's a huge debate in the community on how good state management from Apollo is, right? And you find people talking really good about it, and you're gonna find people talking really bad about it. So it's definitely one of those things that if you do want to do it, you need to really investigate and see if it's the right step for you. But because it's just a state management, right? You can basically break down your state into pieces and then host that with Redux, and partially host that with Redux and partially host that with Apollo Client, and then slowly migrate, right? I don't think it will be nasty, right? You'll be adding a lot of complexity into your application. So again, you really have to think really well how you want to approach that problem. But there's nothing stopping you from doing like a step-by-step piece, or kind of like doing like a big bang migration where you just at one point you drop everything from the Redux and migrate it over to Apollo Client after you feel confident about it. So there's different strategies and different ways you can do it. It's really how complex and how big is your application in your state, and then how you able to maintain and to make that migration happen, and how much resources you got and whatnot. Yeah,
that's good. Yeah. That's it. I think the last question was a general question about like where can I get slides. I think I've mentioned that we are going to post the slides for both talks on the Meetup page and the videos to the sessions themselves. Finally, I'd just like to say thanks to Marlon for the really good talk. He's going to hang around and he'll have his LinkedIn details. I'll put his LinkedIn details at the end of the talk, and if you want to reach out to him for any questions that you have, or you want him to give you some advice on how to apply for roles in Workday, because I know he had some links there at the end of his presentation. Definitely reach out to him. I'm going to pass over now to my good friend and colleague Alvaro, and he's going to introduce our next talk.
Thank you, Stefan. Hello, everybody. Well, next up is George Kemp. He started his HubSpot career 2 years ago here in Dublin before he moved to Colorado in the USA, where he's joining us from today. And a bit of introduction about George. As part of the HubSpot marketing team, he works in a range of full stack projects with a range of technologies. So please welcome him for the first ever Meetup talk. George.
Hello, and welcome to my talk about TypeScript and React. First of all, thank you, ReactJS Dublin, for inviting me and letting me talk. So let's jump right into it. So my name is George. I work on the web team at HubSpot, and we serve a wide range of kind of people, including HubSpot customers, prospective customers, partners, and the wider business community. We host a range of websites, including our academy. We have case studies. We have different applications, including email signature generator, industry benchmark data, Make My Persona, and many, many more. When we started on the team 2 years ago, we were a team of 13. We're now a team of 25, and we're still hiring. We work on lots of short-term and long-term projects, have a range of skill sets, and work across 5 different time zones. And we have to work fast. We've had brand new React projects ideated and launched within the same month to respond to changing trends, global pandemics, and customer needs. With this fast-moving attitude comes a problem, which I'm going to talk a little bit about today and discuss what we're doing on the HubSpot web team to start to solve this problem. We're in a unique position where we're not building one single long-term product, but a bunch of short-term, medium-term, and sometimes long-term micro applications for our website visitors and our customers. Sometimes we work on these projects for a month, sometimes 6 months before moving on to the next project. And when we come back to these projects for updates, maintenance, or bug fixes, we always have to ask the same question. How did this work again? What props did this button need? What are the different options? What's the shape of the response from the API? And inevitably, we'll end up typing something like this instead of this. And of course, my favorite error is the uncaught type error. Those annoying little errors that indicate you probably just misspelled something. Misspelled a variable name or a function name. So, we write docs. They may range in quality, consistency, and helpfulness, but we'll use JS docs, endless README files, and sometimes even a wiki post on the company wiki. But let's be honest, there's none of us here that love writing documentation. We'd much rather be coding. So what if I told you there was a better way? A way to almost self-document your code, a way that made refactoring, bug fixing, and adding new features to a React app as easy and as satisfying as that time when you're wrapping Christmas presents and your scissors just slide right through the wrapping paper. Make your code so much easier to understand that your coworkers will love working on applications that you built. Well, since you signed up for this meetup and you probably read the agenda, I don't think this will come as any surprise, but I'm going to build some tension anyway. There is a way, and it's using TypeScript. And if you've immersed yourself in the developer community, you've probably heard something about TypeScript, whether negative or positive. I gotta say, I think the level of passion that people have on their opinion of TypeScript can sometimes rival that of Star Wars and Star Trek. So, what is TypeScript? Well, it's a superset of JavaScript. A typed superset of JavaScript that was designed to be transcompiled into JavaScript. It was developed in 2012 by Microsoft and is still maintained to them today. Both interest and usage of TypeScript has been slowly increasing over the past 4 years, with last year actually being one of its best years, with State of JavaScript reporting that 78% of respondents had or have used TypeScript. I guess while some of us were making sourdough, the rest were learning TypeScript. So, what's so great about TypeScript? What benefit do my coworkers and I get by using it? And is it really worth the extra effort and tooling? Well, I think you can narrow it down into 3 main benefits. There are many more, I'm sure, but these are the 3 of my favorite. The first, and probably most obvious, is type safety. Type safety really means that when the code is compiled by the TypeScript type checking system, it checks to make sure you haven't misspelled any variables, and you're not trying to divide by a string. And it provides really helpful errors and warning message if something seems slightly off. The second, and probably my favorite, is the Ide integration. Many modern IDEs, including most predominantly Visual Studio Code, are heavily integrated with TypeScript. This gives you a ton of cool features, helpful suggestions, and type checking as you type. VS Code will use types not only from your own code, but from third-party libraries to check as you go and offer extremely helpful auto-completion and validation. Think third-party React component libraries. Gone are the days of flipping back between the documentation and the IDE. If your component library is typed, you'll get the documentation at your fingertips when you type. You get auto-completion, prop suggestion, and validation that you're using those components correctly. Finally, as I mentioned briefly in my last point, is the documentation part. We all love developing reusable pieces of code. In fact, React is built around the concept of building reusable components. But sometimes the hardest part of writing a reusable component is documenting it well enough for others to want to adopt it. For others to be willing to use your reusable code, it must be easy for them to understand what the props do, what's returned from the function and component, and how do we properly use it? So we can spend time using default props, prop types, writing JS docs, but this still requires a user to find the documentation to read. However, with TypeScript, it becomes much easier. As soon as your coworker starts to write the name of the component, autocomplete comes to the rescue, giving them a suggestion of which props need to be added, the options for each one, and will throw an error if something isn't right. Alright, so I've done a lot of talking about TypeScript so far, but not a lot of showing you how this stuff works. So let's get to it. We'll start off with a very basic React component. It's based on our component library and has just a handful of props. But what questions might you have? For one, I want to know what sizes are available, but also whether all the fields are required. We can fix this many ways, with JS docs or prop types. But with JavaScript, it's really easy. All I have to do to convert the specific component into TypeScript is to type the incoming props. Here, I've created an interface where I've defined size, source, alt, and link to be different types. Source, alt, and link are all strings, and size is strings, but it's an enum of values. When I start using this, I get autocomplete options and validation. You'll see here when I start writing size, it brings up the list of values that I could potentially use. And if, for example, I completely ignore that and write big, it'll throw an error and tell me that big is not assignable to that enum of values. Let's look at a slightly more complex component. How about a controlled text input with some React hooks? Again, I've typed the incoming props. I like to put an I in front of the declaration of an interface because it just helps me keep the object and the types separate, but others prefer not to. For this one, again, I typed name, label, and placeholder being required strings, but both initial value and theme have a question mark after the name. That means that it's optional. In the destructuring, I've also assigned it default variables, so if they do not supply them, they have a default instead. You can see in the actual function call itself, I'm using a default React hook, the useState hook. Here I'm passing in another argument before the actual list of arguments. This is a type argument. Here I've assigned string to that value. What I'm telling React here is that what value I'm going to be passing in is going to be a string. And using that information, it can come back and tell me that value is going to be a string, and set value is a function that requires a string to be passed to it. So what that means is when I go to use this, if I accidentally try and set value to the current target of an event versus the value of that current target, I'll get an error telling me that it's not a string and that it won't return me my expected results. Let's dive a little bit deeper this time. We're going to create a reusable hook. It's going to be a debounce hook. It'll take a rapidly changing value, such as the result of a range slider or text input, and using useEffect, it will return the same value but debounced. This can be used to reduce calls to an API or reduce the amount of renders required for children components. All right, so let's make our hook. We're going to be using a combination of useState and useEffect, and we will call it useDebounce. Very similar to how I used useState in the previous example, I've added this argument call, this type argument at the very beginning. For the sake of this function, I've called it t. T is the type of whatever value I'm going to be passing in. As you can see, I have t assigned as the type for that value. I then pass it on to the useState function, which allows TypeScript to deduce that the debounced value is going to be whatever the type of t is. That means when we go to use it, TypeScript will know that whatever is returned from this function is going to be of type t. You'll see another thing in this example as well. I haven't actually typed the variable delay. I've just assigned it a default value of 200. TypeScript's quite smart. It can deduce a lot of different things without ever actually being told. So for example, I'm saying that delay is 200. It knows now that delay is probably going to be a number, and given that I've given it a default, it's also going to be optional. TypeScript does a lot of these things for you. It does its best to understand what types you're using without you having to give it those specific types. Alrighty, let's take a look how I would use this. Again, back to the previous component that we were working on. I've now got debounced value using the use debounce. I pass in string as before. And now this console.log will only run when we finish typing or if we pause for the defined the delay amount of time. So as you can see, React and TypeScript, they work really well together. There's already a lot of ways you can integrate React and TypeScript. But probably the largest benefit comes from when you use third-party libraries. And over the past few years, those third-party libraries have worked really hard to ensure that code is properly typed for you, so you can use it. So you can use the benefit of TypeScript when you develop yourself. So let's take a look at a few of these third-party libraries and how you would use it. So the first is Axios. Axios is a very popular third-party library for making HTTP requests. Here I have a function called getUsers. And traditionally, what would be returned back from Axios from the HTTP request would be unknown. But with TypeScript, I can add some types to that Axios function call using it with a type argument, and it will automatically know that when the promise that's resolved from that Axios.get function call will be of type, in this case, IUser. Again, TypeScript does its magic and understands that when we're running getUsers, we're going to receive a promise of and receive a result of an array of users. This is a really good time to kind of mention that TypeScript can be used on both the front end and the back end, and types can be shared between them. So for this example, IUser could come from the back end and can be managed by the back end teams. And then, for example, if your back end team changed the structure of the response, the front end would know about that. And if, for example, you were accessing a variable that was no longer defined, it would throw an error, allowing you to catch that error before the end user ever sees that. And now moving on to style components. Style components is a CSS in JavaScript library that we use a lot here on the HubSpot web team. And it's used for styling React components. It also allows you to use the props of the actual component and a theme in combination to generate those styles. So to make the full use of TypeScript with style components, the first thing we're going to do is to define what the default theme looks like. So this would be a separate file that you'd have within your React project. You would import style components, and then you would extend it to tell it what your default theme looks like. Then inside your actual, when you add the theme provider, you would declare the theme as the default theme and then pass it into the theme provider. Then later on down the line, when you're ready to use that theme, it'll all be typed for you and you'll know exactly what variables you have. Additionally, you can pass, as I mentioned before, different variables in as props to the styled h1 or div or whatever you're styling to give a way to customize that style. Here you can see I'm adding a size and setting it to the size of the h1. In order to be able to do that with TypeScript, we add another type argument onto the style h1. This allows us to define additional props that that particular H1 will be able to take. Finally, and most importantly probably, would be Redux. Redux is one of the most popular state management libraries used in React. And while you can still use React Redux directly with TypeScript, I like using Redux Toolkit. It makes setup a breeze, especially with TypeScript. So let's look at a very basic to-do application. Bear in mind, I have not done best practices in terms of sorting out this code into separate files. I wanted to kind of keep it all in one file so that it would be easier to show in this presentation, but I don't recommend having all of your reducers, actions, and the store in the same place. But for this case, I've done it. So here, all we have to do to properly type the Redux application is add an interface of each slice of state. So for this example, we only have the to-do part of the state. So I've set the initial state as an empty array, but defined it as an empty array of to-do items. When I create my slice with ReactJS Toolkit, it now knows that the type of the state is going to be a type array of to-dos. I also type my actions, both add and remove, to take in a string. Now I can do the normal setup where I export the actions and export the store, which would be a collection of my reducers. In this case, it'll be a single reducer, which is the to-dos. And at the very bottom, I've added a couple of extra pieces that make this a little bit more useful. So I've defined my own use dispatch and use app selector function that take in the root state and the app dispatch type. That ensures that down the line, everything is typed correctly. Now moving on to the actual use, as we would with normal Redux, we provide the store to the provider. And then when we actually get to the application, everything coming out of the to-dos and dispatch is properly typed. For example, if you accidentally dispatch an action with the incorrect variables, then it's going to throw an error. This can be really, really useful in large, growing applications, or after a long time of not working on it, as it stops you from accidentally adding another variable to an action and ensures you understand exactly what's accessible in the state. So hopefully I've given you some food for thought about TypeScript and potentially using it in your next React project. Getting started can be as easy as adding a flag when you're using Create React App. Just add --template equals TypeScript. Migrating a code base to TypeScript can be difficult, and it's going to be a long journey, but I've seen it happen, and the value it generates is well worth the investment. Here are a couple tips that I have if your company or team is thinking about migrating their code bases to TypeScript. Start small, with the core components first, ensuring they're properly typed. Don't fall down the any trap. Now, while I haven't mentioned the any trap before, it's a common problem in React applications. What happens is you're not sure the type of a particular variable, or there's an error that you just don't understand. You can easily use the any type to tell TypeScript that it can be any type at all. This is great for quick debugging or quick development, but it doesn't give you the type safety or the autocomplete functionality that TypeScript is known for and benefits from. If you find yourself using any a lot, go back and try and find out what is the correct type of each of those pieces. TypeScript and JavaScript can be used together. Don't be afraid to move some files to TypeScript while leaving others in JavaScript until you have time to do it all. Spend time learning. The core of TypeScript is very simple to learn, but as your use cases get more intricate with high-order functions and components, you might need to spend time learning about the different ways objects, functions, and classes can be typed. The HubSpot web team has just started down its own journey to integrate TypeScript into our code bases. And while there are certainly hurdles to overcome, learnings to be had, we anticipate being able to accelerate our development process, reduce experience disrupting bugs, and increase cross-project collaboration. Thanks so much for taking the time to tune into my talk, and I really hope you learned something. Maybe you'll even consider using TypeScript in your next project. If you have any questions about TypeScript, React, or need suggestions on how to start integrating TypeScript into your project, feel free to reach out to me. Thank you so much.
Thank you very much, George. Great talk. Yeah, let's continue with the same dynamic. Now it's time for the Q&A. We have some great questions here. So yeah, first one, do you see any potential drawbacks of adopting TypeScript?
Yeah, definitely. I think with any technology, there's going to be kind of pros and cons. One of the biggest cons, I'd say, for kind of adopting TypeScript into your project is that new members of your team will also need to kind of learn that. It's still not something that's widely known in the JavaScript community. So potentially, especially junior developers to join your team might take a little bit of longer time to kind of onboard onto actually developing on your application. So that's what I think the biggest drawback is. There's certainly other minor drawbacks, such as kind of the compilation time taking a couple seconds when you're developing, which could slow you down. But overall, I think the pros definitely outweigh the cons.
Right. Yep, next one. Well, that one just jump in. Are there situations where the type system breaks down and does not determine the proper type anymore?
Yeah, definitely. These kind of situations do occur. However, the TypeScript community and Microsoft, who kind of actively maintains TypeScript, is slowly working to resolve a lot of those issues. So, for example, about 2 years ago, I started to use React with TypeScript and noticed that a lot of times it just wasn't inferring the correct types or didn't understand kind of the higher order component kind of model. So there will be cases that you might find, very edge cases, I believe, that the type system may break down, but these are usually bugs that are known and that are slowly being resolved.
Okay. Yeah, next question is, do you always reach for TypeScript for new application, or are there situations where you use just vanilla JavaScript, for instance?
Yeah, that's actually a really great question. I try and pick up TypeScript wherever I can because it allows me to kind of jump back and forth to different projects and kind of have good documentation of of how that application was working. But there certainly is a little bit of overhead in actually setting up TypeScript into your build pipeline. And so sometimes if I'm just writing something in vanilla JavaScript with no build pipeline at all, I might, forego using TypeScript and instead just stick with vanilla JavaScript, so I don't need to implement any sort of build system. That's a great question, though.
Great. Yeah, next one is, can you adopt TypeScript gradually in your application? Let's say you work on a very big app and you don't want to make one big bang change. So which strategies or what strategy do you suggest for approaching this?
Yeah, another good question. I think I mentioned just very briefly in the last section with the tips that actually TypeScript can kind of consume as part of the compilation step JavaScript as well as TypeScript. And there's a flag for that when you're actually setting up your TypeScript compiler that you will allow it to kind of consume JavaScript. So you can have TypeScript and JavaScript files working alongside each other and slowly just change all you have to do is change the extension of that file from JavaScript to TypeScript and then add those types. And you can do that slowly across your entire application until, so hopefully at some point, everything's entirely in TypeScript.
Great. Yeah, all right. So in relation to using TypeScript on the backend, can you elaborate on how this is achieved? Because Node.js runs on JavaScript engine and doesn't natively support TypeScript, right?
Yeah, so it's the same for both browser and Node.js is you can't run TypeScript directly. It always has to be compiled. And so for Node, you would set up a similar compilation kind of pipeline, either in a build step or there are libraries that you can use that will compile it and run it at the same time. So you don't actually have to use anything like Webpack or Rollup to do any of those compilations before you run it.
Great. So yeah, this is how do I configure? How can I configure my React developer tools? For instance, hot reloading with TypeScript.
Yeah. So if you're kind of talking about like how would you set up your development pipeline, I usually jump straight for Create React App because it gives you so much of that hot reloading and like the testing kind of framework under the hood. If you want to set it up yourself, there's great documentation for whichever is your preferred kind of bundling library that shows you how to like incorporate TypeScript with that. But there's a lot of great plugins that you can use that will compile TypeScript into JavaScript and still give you that like hot reloading and all those additional kind of React developer tools on top of that.
Right. Yes, so next one is with the popularity of TypeScript and the emergence of new runtimes like Dino that are built in TypeScript, do you see this as a trend that we will continue to see, or this more of a substantial shift in natural evaluation of JavaScript?
Yeah, that's a great question. I think JavaScript, it's the language that's executed against in the browser or in Node.js, so it's never going away. And people will always, there'll be a decent amount of people that will always reach for JavaScript. But I do think the adoption of TypeScript will slowly increase over time, especially as the adoption of it increases across libraries, and TypeScript continues to evolve to be have faster compilation times. And more support. Yeah, so I do see TypeScript continuing to develop, but I don't ever see it overtaking JavaScript in kind of adoption. It is also good to mention that TypeScript oftentimes adopts kind of those early stage proposals prior to it actually being adopted into kind of the official JavaScript code. So oftentimes you can use TypeScript to test out some of those new stage proposals, which kind of keeps TypeScript a little bit more of a desirable kind of language to use because you get to use those faster.
Okay. Is the time it takes to run TSC, the TypeScript compiler, a considerable overhead?
The answer there really is it depends. It depends on the application. It depends on your build setup. For example, if you have a very large application with kind of an unoptimized build setup, it can be a very considerable overhead. But with tools like Webpack, being able to compile particular modules that are changing rather than compiling the whole application, the overhead there is quite minimal.
Great. And how do I define an object that is returned and can have two different interfaces depending on whether, for instance, a request is successful or not?
Yeah, that's a great question. There is a way to kind of do an and/or kind of scenario. I think I may have shown it. No, I don't think I did. But there is, for example, if you had a promise that may return undefined, you can have the promise, the left kind of arrow, whatever is going to be resolved in the usual request. So, for example, in the case that I mentioned in the presentation, it was an array of users, and then you can just put like the pipe symbol and then undefined, and that means that it could also be undefined. And when you're using that function, you'll have to assert that it actually contains something in order for TypeScript not to complain that you might be using an undefined variable.
Okay, and You've mentioned a handful of notable challenges to consider when migrating an existing code base from JavaScript to TypeScript. What are the first steps you will take? And is it just a case of updating your Webpack config to compile a TS file extension and start renaming files, or is there any other configuration to take into account?
Yeah, I think you hit the nail on the head in that, yeah, the best first step is to add that compilation step to your Webpack config and just start changing a couple of the TypeScript of your JavaScript files into TypeScript. There are a lot of different configuration options for TypeScript, and so oftentimes it's just a kind of a task of playing around with those configuration options and finding what works best for you, what gives you the right output, depending on what features you're using. For example, if you're importing JSON, there's a flag to allow you to import JSON and process that correctly. Yeah, just like setting up any kind of build configuration with Webpack, rollup, parcel, you know, there is a little bit of experimentation that's kind of required.
Okay. Mm-hmm. And another question is, how does TypeScript compilation work behind the scenes? Is it transpiled with Babel or any other transpiler?
Yeah, so what TypeScript does is it's kind of a two-step process. The first thing it will do is it will actually type check everything for you. So what that means is it will go through your code and make sure that everywhere that you're using a variable, you know, it's the correct type that you're expecting it to be. You're not calling a function that is undefined. And then the second step would actually be the compilation. Both of these things are kind of done with the TypeScript code base itself, so the TypeScript compiler and type checker. And then you actually do have plugins for kind of Webpack, for Babel, that will run TypeScript as part of their build step.
Mm-hmm. Okay. And the last one for today, do you think browsers will support TypeScript natively at some point?
I don't think so. And here's why. I think TypeScript, the benefit of TypeScript is really to the developer, to allow them to kind of check their work and run that type checking on compilation, including those types in the end code, wouldn't really provide any benefit to the end user, and would just increase the actual size of the code. It's you know, you can kind of think of types as almost comments. You know, when you're compiling your code, you don't really want all the comments in that final code that you're shipping to the end user, because it's really just bulking up the code and it's not really providing much value to the end user. So I don't believe that TypeScript will ever really be natively run on a browser.
Okay, yeah, great questions, great answers. Thank you very much, George. I'm gonna pass it on back to Stephen, who's gonna wrap it up.
Thanks very much, Alvaro. Thanks, George. Great presentation. Yeah, so that's our meetup for tonight. Really happy to have you all here. We will be posting the videos onto our YouTube channel shortly when they're available. We will be posting the links to the slides and some other links onto the Meetup page. If you would like to speak at one of the events in the future, please reach out to us through the Meetup page. If you'd like to see a talk but don't feel comfortable or don't feel confident enough to give it yourself, please use that form as well, and I'm sure we can find somebody to give the talk on your behalf. Once again, big thanks to HubSpot for sponsoring this, for the AV stuff. Thanks to Michael on the AV who helped us out tonight, and thanks to all of the core ReactJS team. We're all contactable through meetup.com/ReactJS. We have a feedback survey going out soon as well after the event. Please be honest and give us some good feedback, and we'll act upon it. And we'll also have a think ourselves about when our next virtual event is, and we'll announce that shortly as well. So all that's left for me to say is thanks very much, and everybody have a safe evening, and yeah, we'll see you all soon. Thanks a million.